All right, folks, this is the next part of the series combination circuit. So we need to find our current right here for this part of the circuit, which is the parallel circuit, and we fall under parallel circuit rules. Our voltage has stayed the same, but now all of the currents that these resistors are taking have to add up to 3.30 amps. Okay, so to do that, we use Ohm's law, volts divided by our resistance, because that's what we have. So we have for resistor 2, we have 20.89, which is the circuit, this part of the circuit voltage, divided by 10, which equals 2.89 amps. For the third resistor is 20.89 divided by 30 amps, or excuse me, 30 ohms resistance, which equals 0.69 of an amp. And for the fourth resistor is 20.89 divided by 40, which equals 0.52 amps, okay? Now, just like we had up here with voltage, they have to add up to the total. Same thing with these, 0.52, 0.69, and 2.89. Those have to add up to 3.30. And again, with the rounding, the number may not come out exactly. It typically comes out below, and it'll be a couple of numbers off. No big deal on the learning part. Okay. So now I'm going to go ahead and add these to our matrix. So again, to do our checks and balances, we can do our 2.89 plus our 0.69 plus our 0.52, and that has come up with 4.1. Let's check our work again here real quick. Okay, this is where we went wrong. This right here is not correct. That should be 2.0. So and this is again the part about checking your work. So we're going to do 2.09 plus 0.69 plus 0.52, and that equals 3.30. You can see that in the calculator, okay? So our numbers here are correct. If we, like I noticed, I put 2.89, and that made the number way significantly too high. I put an extra amp in there. So I went back and checked my work here at the 208, or 20.89 divided by 10, and the number actually came out to 2.089, and I just rounded that up to make things simpler, and the number came out, okay? So that's how to find the majority of that. With the power, I'll show you the power also in the next video.